Welcome on our DataOps Poland meetup, our guest from Redis Lab. Welcome you, our stars today, and stage is yours. Time stop. Yeah, Kamran, it's.
Thank you. Good afternoon, everybody. Thanks for the opportunity to present here today. Really appreciate that. My name is Markus. I'm based in Helsinki, Finland. I'm responsible for Redis Labs business in the Nordic and Eastern European region. Been with the company for 3.5 years. And before my Redis Labs career, I used to work in a similar role for Couchbase for 2 years. And before that, I was at Red Hat for 6 years. So bit of an open source fast data background. We have prepared an agenda for you today. I will first cover an introduction to Redis and Redis Enterprise, how we see some market trending, what are the key differentiators of Redis that we see in the markets, what are the common use cases where we see of people using Redis, how they use Redis. And then we're going to cover an introduction to the Redis modules. And then what is Redis Enterprise offering and how we cooperate with the Redis open source technology and community. And this will take roughly 25 minutes in the beginning, give you some context and background. And then the main part of the session will be managed by my architect, Kamran, who will give you an overview of how to run Redis in a cluster configuration, actually a demonstration of that. And then we will cover some common Redis use cases from a developer viewpoint. What are the best practices when you're developing with Redis? What different options you have available? And then an update on recent release of Redis 6 as well.
Sorry for interrupting, but we see that one of the page on your web browser, I mean Zoom, so not sure it's Planet or there should be presentation.
And the presentation is there now. Yep. And this presentation will be useful for you, even if you're not using Redis Enterprise, but you're interested in using Redis as an open source. A lot of the things that we say will apply accordingly, and we will make it clear when there's a difference between Redis Enterprise and Redis open source. As we move along, please don't hesitate to raise your hand and ask questions. We are here to provide you the best experience and information on Redis. So, Redis is an in-memory database platform out there in terms of popularity. Redis Labs, on the other hand, is both the home of open source Redis as well as the enterprise provider for customers who require enterprise features like high availability, scalability, security, and SLA. We employ the core engineers working on Redis core. The founder of Redis, Salvatore, works with Redis Labs. And the origins of Redis Labs are actually in the cloud. So we were cloud born. Our first service back in 2011 was Redis as a service on AWS backend. Nowadays we support Azure and GCP as well on our managed service. And we have a software version for self-installation. We got roughly 9,000 enterprise customers globally that are paying Redis Labs for the service. Clearly, the open source footprint and usage of Redis is a lot bigger. Some market statistics, and I apologize for the outdated slide, but it gives you the trending. This is Docker Hub statistics, and you can see that Redis is downloaded more than the rest of the databases together. It's by far the most popular database on containers globally. Last autumn, we bypassed MySQL as the #1 database on AWS Cloud. And this is not comparing NoSQL versus relational technologies, but all database technologies together. In Azure, we are #2 or 3, and same applies for GCP. So take a public, Redis is one of the top 3 databases deployed and used and consumed in those environments. Redis is also quite a bit loved by the developer community. Stack Overflow survey, now actually 4 years in a row, the 2020 results came, and it's still the same. Redis is, according to over 100,000 respondents, the preferred database technology that developers like to work with. So what makes Redis so popular? how is it different from other technologies? What's exceptional about it? I think at the level we've identified 3 top differentiators for Redis. The left one on the right, the left one, number 1, performance. This is the public image of Redis. Redis is perceived as the fastest cache. And that actually holds a lot of truth in it. Redis is written in C. It's single-threaded, runs in an event loop, lock-free. There's always, Redis development always favors performance and simplicity over functionality if a trade-off is to be made. So take any benchmark out there, look at the hardware configuration, how much throughput and what are the latency characteristics on that benchmark. Redis tends to lead the pack in those comparisons. However, from a developer viewpoint, we believe that the biggest differentiator of Redis is the one on the middle called simplicity. And with this, we refer to the data type nature of Redis. Redis is a key value technology. You have a primary key, and through that key, you access the value behind the key. In Redis's case, the value is actually a data model or data structure, if you will. It can be a string, which is very commonly used for your, for your caching use cases. You get a string of data or a binary blob of data, and that's your value. That's a very simple use case. If you're using Redis for session or profile management behind your online application, for example, you are likely to use the hash data type, and Redis hash is just a regular hash. It's a combination of fields and values. That is ideally matching the session attributes, for example. You can update the session counters, do atomic operations on session attributes with sub-millisecond latency in scale using the hash data type. There is also a list data structure with Redis, and this is turning Redis into a FIFO or LIFO queue. So you can add elements left or right to the queue, and you can pop from the other end. And remember, Redis is single-threaded. It provides atomicity guarantees that are very nice. For example, if you're using Redis lists to sell online tickets and you have 10,000 available, you can guarantee that you're only selling 10,000. Even if there is somebody requesting a ticket a microsecond later, that ticket is gone from the list. It's not available anymore. There are more complex data types in Redis. For example, sorted sets. This is a set that maintains a score on the value. Most of the popular gaming companies are using this data model to maintain up-to-date leaderboards, for example, to their games. And you can understand the dilemma from a developer viewpoint. If you have a popular game that has 1 million updates per second on the game statistics, how do you display up-to-date leaderboard with that velocity and amount of data? Traditionally, you would need to download a lot of data to the application memory, sort it out and write it back, and you're already behind when you do that. With Redis sorted sets, you can always read the 10,000 values from a sorted set, and you got up-to-date leaderboard. In banking and finance, this data model is used a lot for maintaining the latest prices and bids on a highly volatile trading environment, for example. GeoHash is another more complex data type. This is basically maintaining longitudes and latitudes and the proximities in an optimized hash. The biggest user of this data model is a dating application called Tinder that is using this for their global dating service. They have tens of terabytes of distributed data and distributed Redis. And again, this providing the up-to-date matches on a radius scan on a proximity with highly movable mobile phones in this case would be a very hard problem to do on a global scale. But with this GeoHash data type, you can just do a single request, give me the matches on this with this radius, and you get a sub-millisecond response from the geospatial index. Again, something that would be very hard to solve using traditional methodology. And this is a prime example how Redis can offload complex data manipulation tasks from the developer's code back to the optimized algorithms to the data tier of distributed Redis. And we in Redis Labs, we believe that this goes a long way explaining the popularity of Redis in the developer communities. Redis data models help solve hard problems with super nice and neat solution and in a performance that is unparalleled in the markets. One of the data types that could be new to some of you who might know Redis from the past is streams. This is the latest addition to Redis data models 2.5 years ago. And this is providing Kafka type guarantees, but in Redis's way. So you can take lookbacks to the stream. You can have different consumers or consumer groups progressing at the data at their own pace, different acknowledgement and pending routines, depending on your needs. And it's super fast and lightweight. You can easily create thousands of streams with a very, very modest footprint in Redis style. And you get sub-millisecond latency, tens of thousands of additions in a second easily in a modest computer. So these are the 10 data types that come out of the box with Redis, and they explain a lot of the popularity that Redis has in the markets today. The third high-level differentiator on the right is extensibility. And with this, we refer to the concept of Redis modules, which is our strategy for expanding the functional scope of Redis. So if these 10 data types and the commands provided are not good enough, you can create your own. Here are some of the popular modules that have been built since this concept was introduced. There's roughly 30 modules in the module hub. And we in Redis Lab, we take the most stable and used modules, we run them through our QA, and we offer them support as part of our cluster Redis. The most popular module so far, on the top right corner, called Redis Search. This is the fastest free text matching engine on the planet. It provides you stemming and free text matching over distributed hashes. So if your Elastic or Solr clusters are not quick enough or real-time enough, this could be a perfect solution for you. We have a module for graph, which is turning Redis into a graph database. So if you need to run a graph operation or get a graphical representation of your data, you can plug the graph module. If your data model is JSON, using the JSON module, you can do sub-element modification or updates rather than getting the whole JSON string back to the application. You can just touch the elements that you need. If you need to do TimeSeries, processing, aggregation, sampling, or compression, you can use the TimeSeries module and turning Redis into a TimeSeries engine. There are also a lot of real-time analytics modules, stream counters, Bloom filters, Cuckoo filters. There's a rate limiting component if you're using Redis as a rate limiter in your microservices environment. So there's a whole bunch of stuff that the customers have built. If you have a need to develop over and beyond what the basic Redis is providing today, have a look at the module hub. Chances are there's some already a work that could be beneficial for you. So now I've covered kind of the high-level market presence, high-level differentiators. Let's now jump into some common usage patterns that we see on the field. Here in this slide, we have some buckets where we see repeated usage on our customer base. This is not a comprehensive list, but just some areas where we see a lot of customers using Redis. For example, e-commerce, and this is website caching, session management, profile management, any transient data that you need to access frequently with sub-millisecond latency. That's a very good use case for Redis. You tie that with personalization, meaning personal session path, personal inventories, personal advertisement, personal routing information for the session, etc. Again, a lot of Redis uses there. Search, I mentioned already. This is becoming so popular, it might become a separate product going forward. On social apps side, we see Redis used a lot for maintaining subscriptions to messaging channels, chat rooms, communication groups, providing message delivery capabilities, one-to-one, one-to-N, with confirmations. There's a lot of Redis uses in that area. On finance, we see fraud detection being one of the repeated use cases. In my region, for example, Nordea Bank is using Redis for this capacity, among other things. And actually some of the team is from Poland for this project. But you can see that, you can understand that in fraud, you need to do sub-millisecond scoring when the transaction comes in to define if it's good to go or if something, some other action needs to be taken. So Redis is often used as a scoring engine or enriching the data before it goes to the scoring engine itself. Redis is also used a lot for metering, and it's a very effective counting mechanism for different things. You can keep a lot of counters with very, very small footprint. You can do approximate counts or accurate counts depending on your needs with different trade-offs. For example, counting sessions, page impressions, SNMP traps for a mobile network, how many there are coming over a sliding window, is the network fine, is it good or bad, etc. There's a lot of use cases around metering and counting that Redis is being used for. On IoT use cases, we see a more write pressure towards the database and turning a real-time index of view for the consumers of that data. So these are some of the areas where we see a lot of Redis usage in the field. However, the biggest thing when assessing if a use case is good for Redis is the one on the middle called real-time. If you have a need to manipulate or process or access your data in real time, chances are that it's a good use case for Redis. Turn that around. If your use case is more about archiving, you put in data in a storage and you come back 3-6 months later to access that data, don't use Redis for that. There are better technologies for those type of use cases than Redis. Let's take slightly different categorization of the use.
I'm sorry, we have one question.
Sure.
What really differentiates Redis with other in-memory NoSQL database cache offerings such as Apache Ignite, GridGain, or Memcache?
A very good question. And let me actually take this slide to answer that and start an answer. Because when we look at different types of use cases, on the left-hand side, you can see transactional use cases. And these are bread and butter for in-memory key value technologies. So these are the session management, authorization, caching, etc. In this category of use cases, we are replacing technologies like Oracle Coherence, Hazelcast, Aerospike, Memcache, Ignite. You know, the in-memory key value technologies are present in this category of use cases. Why Redis is being superior in terms of popularity and adoption against some other technologies is the quality of the code. It's written with simplicity and performance in mind. And remember what I said earlier about the data types of Redis. This is unique capabilities that Redis can provide to simplify the code, simplify the task for the developer, to provide accuracy where it would be very hard to do with other technologies. So it goes to the underlying architecture and the implementation of Redis, where we can provide better performance and more functionality, and more importantly, different types of guarantees for different operations. If you need atomicity or using as a transaction engine, the single-threaded nature of Redis is super simple to use. If you're using some other type of technologies, you need to lock the element, check afterwards if the lock was holding, etc. It's a lot more complex to develop in a lot of use cases using different technologies. When we go to analytical use cases on the middle, these are the counters, leaderboards, recommendation engines, session analysis. We see slightly different competition in the markets as well. CRM system providers, business solution providers that have the data that is needed here come with reports and capabilities in this area. We see some competition from other in-memory technologies as well, but they come from a different angle, because we in Redis, we rely heavily on the Redis data models and data types to provide these capabilities in scale and with sub-millisecond latency. That's the differentiation here. When we go on the right-hand side, the operational use cases, these are corporate search, inventory tracking, order history, accelerated reports, Black Friday, offloading, some of these things. Slightly different competition again. ERP system providers have this data. They come up with the capabilities on this area. So depending on the types of use cases, we see slightly different dynamics in the markets. As to answer the question, we see the in-memory key value technologies more present on the left-hand side, the transactional category. You will understand more how it's different from them as we go through.
There is another question. How does the single-threaded nature of Redis affect its throughput under high load?
Very good question, and this is exactly some of the differentiators that Redis Enterprise can be.
I think Markus, in the more technical detail, I'll be able to answer that question also.
Absolutely, because but it is a very valid question. You know, how do you scale if you're single-threaded? Let's look at quickly some of the customers that we got, and you can see here Redis is widely used across different industries. There is no killer application, there is no killer industry for Redis. You might say that banks and finance are the biggest in terms of revenue to Redis Labs, but they are not by far bigger than any other industry. In this region, we have customers ranging from Nokia, Ericsson is using Redis, Nordea I mentioned. We got Air France, KLM, Thomas Cook, Kiwi, you know, different companies are using Redis for various things in a lot of capacities. You find new use cases when you discuss your customers every day. Now, let's jump into the Redis enterprise offering and how is that different from Redis open source. And this is starting to provide some of the answers. What can you do with a single-threaded technology, take it over and beyond? First, before we go there, it's good for you to understand that we are the Redis company. Redis open source is our base product. We don't fork this in any way. If your application works with Redis open source, it will work exactly the same with Redis Enterprise. That said, we have developed some features that are only available to our enterprise customers. For example, on the top right corner here, tiered access is such a feature. This is Redis on Flash. And this capability allows you to store bigger data sets in Redis in a more optimized infrastructure footprint. So this is basically a RAM extender capability. So if you're having terabytes of data in Redis, it becomes expensive to source that RAM estate. Up to 85–90% of code values can be evicted to SSD and still maintaining sub-millisecond latency for your operations. This is only available with Redis Enterprise. Active-active is another enterprise-only feature. This is a capability of running multiple independent Redis clusters, typically in different data centers or cloud regions with local high availability, but sharing the same global data set. So this provides you capabilities of doing local latency reads and writes in each data center, but sharing the same data. This relies on a CRDT, which is the academic consensus for providing replicates, basically resolving the potential conflicts if you write into the same key in multiple places before the synchronization happens. And there is a resolution strategy for each Redis data type out there, and this is a very, very powerful feature if you need global distribution of data and operating still on the local latencies. But you have to understand the resolution strategy against your data model to understand what is my strongly eventual consistent value if there is different failure scenarios happening. Now, Redis Enterprise offering is clustered enterprise grade Redis. So basically, we take Redis from a single instance transient cache, which is the most common use case for Redis open source, and turn that into a distributed, reliable memory-first database. We provide linear scalability. We recently launched a benchmark for 200 million operations per second with sub-millisecond latency, 100 million reads, 100 million writes per second, with 40 nodes in AWS. This is unparalleled in the industry. With Redis Enterprise, you have high availability with instant failover, with no data loss guarantees, which is not something you can do with Redis open source. We have durability at memory speeds. For example, the German stock exchange Deutsche Börse is using Redis as the primary database for their transactions. They've tested with 5 million writes per second, every write to the disk before you release back to the client. So with Redis Enterprise, you can really use it as the primary database if that is your desire. Security means encryption between the client and the server, between servers on the cluster, and between clusters if you have a multi-cluster topology. We also provide RBAC for the administration, as well as access controls for the data path itself. Multi-model means the concept that you can plug in the modules that you need for your cluster configuration and scale them. This is only available with Redis Enterprise. We have flexibility on deployments. You can consume Redis Enterprise on cloud as a self-install or as a managed service from Redis Labs. You can install it on premise, on hardware, virtual machines, on Kubernetes, whatever platform you prefer, or you can run a hybrid or multi-cloud configuration. With Redis Enterprise, as you will see, it's super easy to replicate data from one cluster to another and create a replica of it. The software is always exactly the same in all these models. And then we have enterprise-only features like Redis on Flash and Active. All comes with an easily manageable package that you will see in action very soon. Now, let's jump into the technology more. This is Redis Enterprise Node. It consists of 2 layers. The red layer is the open source layer, and these red boxes are Redis instances or processes or shards, as we call them in Redis language. Most common way of using Redis open source is that your application connects directly to the Redis instance for gets and sets, and that's all good and fine. Redis is very performant. You can easily get tens of thousands of operations from a single process. But, and this is going back to answering some of the questions that was asked, you're still using one CPU core and the RAM associated with that core. If you need more capacity that one provide, then you have to launch another process, typically in a different node, and partition the data on the client, which becomes cumbersome to manage in scale. And other drawback of this mode is that if you have no replication and you lose that process or you lose that node, your data is gone. The blue layer, the enterprise layer, comes there to fix that. It has 3 logical components. The most prominent one is the zero latency proxy, and it acting as a highly available endpoint for applications connecting to a database. So rather than your application connecting to Redis instances directly, they go through the proxy. And the proxy is there to hide the cluster topology of Redis Enterprise Cluster. So your application believes I'm talking to a single Redis instance, whereas in fact there could be 10 master shards and 10 slaves on different nodes, providing the capacity needed for that application. Proxy does other things like multiplexing and pipelining as well, but the main function is to act as a highly resilient endpoint and hiding the cluster topology. We have a cluster manager that maintains the health of the cluster, makes sure there's always a slave configured for each master. It enforces the configured persistency options, promotes slaves to masters if there's a failure, and maintains the quorum on the cluster. We have a REST API for monitoring the cluster or commanding the cluster. You can automate all things using the REST API, or if you're running in Kubernetes, the operator will use the REST API to set up the pods and the cluster. You need 3 nodes minimum. Any odd number of nodes will do for a distributed application like Redis Enterprise. And you can scale up by adding more processes or databases to the same nodes, or scale out by adding nodes and distributing the processes to those nodes if you need more network bandwidth or more compute, for example. It's good to know that this platform is multi-threaded. It's multi-tenant in a sense that you can have multiple databases in the same hardware, totally independent of each other. It's process level isolation. The data they will never cross each other. But the database configurations could be totally different depending on the capacity and guarantees needed. This is where I will stop. This was an introduction to Redis, how we see the market, where we come from as a Redis company, being the Redis Labs, and what are the common use cases, and bit of an intro to Redis Enterprise. And now I will hand over to my architect Kamran to show you Redis Enterprise in action, and take it to the next level in terms of understanding how you develop with Redis, and what are some of the peculiarities, do's and don'ts when you're developing and working with Redis. Any questions at this point? Go ahead, Kamran.
Thank you. Thank you, Markus. And I hope that everyone can see my screen right now. Guys, can you hear me?
Yes, I can see it, yeah.
Yes, all right. Okay, so I think we do have a technology glitch. So let me just sort that out first. Because I did want to do some drawing, and right now, Sorry, just bear with me. Yep, we are good. Okay. So Markus, where he left off, Markus explained the architecture for Redis Enterprise cluster. What I'm going to do is that, first of all, I will go through, I will give you a demo about Redis Enterprise, where I will show you that there was a question, how do you scale for Redis? So I will go through a demo and show you for how Redis Enterprise works. Once I've shown you Redis Enterprise demo, then I will dig deeper into the Redis different data structures and show you examples that how those data structures can be used to solve your business use cases. In the meantime, if there are any questions, please raise your hand and ask me any questions, and I will answer those questions for you. So first of all, for the demo, what we will do is that I have a Redis Enterprise cluster. I am running it on Google Cloud, but it is no more different than what if you are running in your own data center and you have installed the software yourself. I have 3 nodes in on Google Cloud virtual machines, and what we will do is that we will create a single database, which will just be a master, just a single Redis process, and then we will start a new an application, and I will use memtier benchmark. That's an open source tool to generate load on our database to the highly available endpoint. While we are, and we will try to generate a reasonable amount of load. Let's see how many operations we can achieve there. Once I have started generating the load, this database, it is not highly available. On the fly under load, we will make it highly available, and we will instruct the cluster manager to start a new replica. When we start the new replica, it will start replicating the data to the database. It will start replicating the data. So now it is highly available. And in case the master goes down or node 1 dies, we still will have high availability and the replica that can take over. Then I will show you that how you can also scale Redis. Redis is a single-threaded database, or more accurately, it is most of the time single-threaded. What that means is that when it is touching you, when you make a request, it's touching the data. That's where it's single-threaded, so that's why it gives you the atomic properties. But after that, on the network side or on the persistence side, it can use more threads and more CPUs there. Okay, but still, if you want to scale, your data is growing, or a single core for your data cannot achieve the operations that you require, the way you scale is that you start a new master, and that's what we'll be doing. We'll start a new master, and then what will happen is that half the data that in the first master and half the data that will be in the second master. And for operation processing, we are also using now 2 cores. And of course, there will be a new slave that will be started, and it will start replicating the data there. So you always have high availability in case of a failover there. Okay. One thing to notice during the demo is that you will still be using the application that still will be using the single highly available endpoint. Okay. And then I will also show you the failover that we will pick up one master and we will kill it and see that how long does it take to do the failover there. Okay. So any questions, anyone so far?
I would like to ask one. What about if we will lose 2 nodes out of 3 when there is replication on 2 only?
Okay, so if you lose, so first of all, you need with Redis Enterprise, you need at least 3 nodes there. Okay, and you need an odd number, so that is for the quorum. One thing that Redis Enterprise supports is that when you have one master and one slave, but normally when you are running it, you will run the master and the slave in a different zone or in a different rack. So you are trying to reduce the chance that both nodes goes down. Then Redis Enterprise, then you also have active. So what you can also do is that you can set up an active cluster setup where you have another copy of the data. The other copy, it can be either active or it can be active passive also. So you can have more copies. So even in case that the both nodes go down, you still have your data. Does that answer your question?
Yeah, sure. And we have one more. Single-threaded Redis nature prefers high-frequency CPUs.
That is correct. That is correct. So that because Redis is the core engine, it is single-threaded. So as the CPU frequency goes higher on the CPU, you will get better performance there. That's one. But also remember that you can also set up a cluster in Redis. So as more cores are available, again, you can scale with that. But for a single process core, that's exactly correct. Okay. Does that answer the question?
Yeah, I think so. Okay, yeah. Thank you.
Okay. All right. So now let's go to the demo. So as I mentioned, I am running this on GCP. I started 3 virtual machines. I'm using Ubuntu operating system, but you can also deploy it on Red Hat. And then I'm using I have 3 machines. I have 2 clusters here in case I wanted to show active also, but one cluster that is in US and the second cluster that is in Europe. Okay. And this is the Redis Enterprise Management Console. It makes everything much easier for you. But do remember that everything that I am showing here, a lot of the things other than the clustering technology that is different in Redis Enterprise, most of the things you will be able to do in Redis Enterprise other than scaling and failover as well that you can do in Redis Enterprise. Okay. When you're creating a database, you have 2 options. You can create a database in either a single region, or you can create a geo-distributed database which spans across multiple data centers, and it uses the CRDT technology to do merging or resolving the conflicts with the local latency. One other thing, Redis Enterprise also supports Memcache protocol, because the Memcache commands, they are kind of a subset of the commands that Redis provides. So there is a protocol adapter available also for Memcache. So if you are using Memcache and you want to make it highly available, you can use Redis Enterprise for that. So now let's create our database.
Sorry, we have one more question about the previous topic. Can this master-slave setup have issues if the master and slave get separated on network level, but both keep working and serving requests?
Okay,
similar to split brain problem with other databases.
Okay, so that is called split brain. You will get a split brain in case if you're using Redis open source. In Redis Enterprise, each node on a Redis Enterprise is running its own watchdogs and the quorum that is done on the node level. Okay, so there are multiple processes running there, and the quorum that's done on this. So this will in Redis Enterprise, if there is a split here, the majority of the nodes they will take over. Okay, so a split brain that will not happen in Redis Enterprise because the quorum that is done at the node level. Okay. And always you need the majority of the nodes for the cluster to be operating. Okay.
Okay, nice.
Okay, so now, okay, so without further ado, let's create a database, and everything that I am doing here, this is the Redis management console. There is a REST API also available. If you want to provision, you want to build your pipeline and you want to provision your databases, you can also use the REST API, and there is also a command line tool that I will show you later also. All right, so let's create a database. So now that's part one of our demo. Okay, so I'm creating a database, just a single shard. It has I'm setting up 10 gigabyte of RAM. And one important thing to remember is Redis can also provide you with persistence. So if you want to set up, depending on your requirements for each database, you can say that append only file, and you can also do an fsync every second or every write. Okay. And in Redis Enterprise, it is outside your critical path, the persistence that is done on the slaves, so it does not impact any performance. It comes for free. And that is one of the main reason for that is the way that we have implemented the clustering, and each machine or node, they have the watchdogs that are monitoring. Okay, you can set up persistence. Let's set up the port for our database, and then you can also set up clustering. You can also set up OSS cluster API. If you're using Redis as a database, you can set up as a cache. You can set up different eviction policies there also. Okay. For security, TLS, that is also supported, and you can use X509 certificates for client-side authentication and encryption also. Okay. Redis Enterprise, this is batteries included. What that means is that everything that you need to run a production system, it is included: alerting, performance monitoring, integration with Active Directory, all those things, they are part of Redis Enterprise. Okay, and I will cover the Redis modules, but the certified modules, they are also bundled with the Redis Enterprise there. Okay. Now, without further ado, let me just create the database. So now I've created a database, and it is giving us this highly available endpoint. Okay. Now I will use this, and remember, right now we are just using a single Redis process here. Okay. Now let me just start generating load there, and I will use memtier benchmark, open source tool available on GitHub. If you want to use it yourself, you can use it yourself to benchmark Redis there, and it's also used to benchmark memcache also. Okay. So a few parameters, I'm saying that, okay, read and write 1:4 ratio, run it for a certain period of time. My data set size is 150, start 12 threads. Each thread, it should start 5 connections. I am pipelining, so I'm bunching a few commands, and then I'm passing the highly available endpoint for the database that we just created and the port for that. Okay, and let's start generating some load. Okay.
Meanwhile, we have one more question.
Yes.
Isn't an active cluster implementation risky in sense you are simultaneously writing data to 2 nodes, which may result in data mismatches as in MySQL?
No. The simple answer is no. If we have time, I will cover that, because what CRDTs are, they are conflict-free replicated data types. What that means is, imagine you have to, I will just give you a very simple example. Let's say you have a counter. Redis supports a counter for you. You have counter 10 in US, you have counter 10 in UK, okay? Now, you increment the counter in US by 2, it becomes 12. You increment the counter in UK at the same time by 4. Now it has the value 14, okay? When the synchronization happens, then the end value should be, if you don't want to lose any data, 16. Because you are doing an increment, you want to apply both operations. And for each Redis operation, because Redis uses data structures, and that was the research behind CRDTs, about 5-10 years of research. A university in Italy, they did the research for that, and for each data type, sensible operations for merging, they are done there, okay? So you do not lose the data, or they do not overwrite. Only one case where data is overwritten, if you're using just a string data type, and then in that case, the last write wins there, okay? Does that answer your question?
Okay, I think so. And one more. How data are replicated from master to slaves? Are data exactly the same as in master node, or data is split? And what will be if one of replication node dies, or in opposite, if new node joins the cluster?
All right, well, I will show you that to you in the demo. But again, here, again, a big difference from any other in-memory technologies. That's where the efficiency and the clean code that comes in. Now, remember, Redis runs has commands, which I will cover shortly. Okay, so now let's say if you add something to the list, it is just that operation that goes to the replica, not the whole data is written. So the replication mechanism, it is extremely efficient compared to other technologies where you have to take the whole Java object, serialize it, and send it to the replica. Okay. Okay. So let me just carry on, because otherwise this session, it will go longer. Okay. So now I am doing the operations here, the matrix. If we just go to the matrix, we are doing about 758 operations per second with 1.6 millisecond latency. And that is a single Redis core. That is the performance that you can get with Redis. Okay. Now, because this is just a single, not highly available. Let's make it highly available now. Okay. So all I need to do is go to edit, and now enable replication there. Okay. And again, what I mentioned, that Redis posts track zone awareness, so you can label, so they are in different zones or racks, the replica. Okay. Now I've updated this, and now it is starting. Now, if you go to the client, you will see that there is no impact on the client application. It still keeps on working. It still is sending a load there. Okay. Now is a good time to show you the command line tool. I'm logged in to one of the nodes, and if I just do RL admin, and if I just do a status there, you will see that, okay, I have 3 nodes. I have one database. That database, it has a master and it has a slave. They are running on different machines, and this is the highly available endpoint there. And it did not have any impact on the client there. Okay. Now, if I want to scale the database, that I want to do more operations per second, or I want to do my data set size has increased, and I want to distribute it across multiple machines, all I need to do is, again, edit and do database clustering. Now I will have 2 masters and 2 slaves there. And all I need to do is just update it here. Okay. Now, once I've updated it, if we go back to the client quickly, you will see that there is no impact on the client. The client, it keeps on working there. Okay. And all the data sharding, taking half the data, starting a new process, moving half the data to a new node, new shard, and starting a slave also. That's everything is happening in the background. If we go now and do a status again, we should see that now our database, it has two masters and 2 slaves. The masters, they're running on node 3, and then we have 2 slaves also there. Okay. And if we go to the performance, we can see that the performance has gone up. The latency also, it has gone down. Okay, for us. Okay, so now we are achieving about 1 million operations per second. Okay, now next thing, let's do a failover. So I have 2 masters on node 3. So here I have node 3 here. Okay, and now let's get the processes there. ps minus ef grep redis minus server. Okay, so these are our 2 nodes. Let's kill both of them. Okay, kill -9, and we will use -9 so that we are doing a hard kill there. Okay, and the process ID for the second master, I will do that. So now our expected behavior is that these masters, the slaves, they will become the master. All the traffic that will start going to the new masters. For the client, there will be in-flight operations. The client will get some errors, and then it will start sending the traffic to the new slaves. And the cluster manager, it should start 2 new slaves. So we always have a high availability there. Okay, so now let's do that. I have killed those. And now let's go to the client quickly. So we can see that the in-flight operations, they dropped. There is a pause while the election is happening. And now in about 5 to 10 seconds, see that the operations, they have started to go to the new masters. If we go here and do a status here, again, you will see that that is our expected behavior. The slaves, previous slaves, they became masters, and 2 new slaves started, and they start getting the data that started to get caged there. Okay. Any questions, guys, on this? So
I would like to ask if this graphic user interface is available on open source, or this is only enterprise?
This is only available in Redis Enterprise, but for developers, there is a tool called Redis Insight that you can use, give you the operational capabilities, but you can see the number of operations and things like that, and we give it to you for free.
Okay, thanks.
Okay, all right. So now, okay, so I've gone through the Redis Enterprise, and remember, Redis Enterprise, it is multi-tenant. You can create multiple databases, and all the different databases, they are running in separate processes, so they are separate from each other. Okay. And you can create different kind of databases. You can create a standard database, that what we started with. You can create a database that's available, and then you can have a cluster database where the data that is distributed across multiple masters. Okay. So so now I am going to click on the common use cases and move to the more developer side of things. Okay. One thing I do want to mention before I go there is that I think I will just start a new, that don't be overwhelmed by the commands there. Everything that I will be touching, everything is documented there, and I will give you samples of a few commands there also. Okay. So now Markus, he mentioned that Redis, the main popularity is a simplicity. Redis is a key value store. It's not a relational database. It's not a document-based database. It's not a graph database. It is, in a sense, a key value store. What that means is that you have your key, and then you associate a value with it, and that value, it can be a data structure there. Okay. And we will cover a few different data structures. Just one thing I want to mention is that when I said that it's not a graph database, it's not a document database, there are modules available that will make Redis into one of those databases. But the sense is that you associate your data with the key there. That is the key to understanding Redis. So you have the string data type, the simplest data type for Redis. It has the get operations, it has the set operations, and then you can set up the common operations that I want to delete the key, I want to set an expiry on the key, and I want to append some value, or you can also use it as a counter step. Okay. Then the other one is the hash data structure. The hash data structure, you can just think of it as a Redis inside Redis. There are field names, field names, field names in there. And you can add up to 4 million fields for hashes, and we will go through the different use cases. If you are using user sessions, if you are using user profiles, or if you are moving from a relational database and you want to put a row inside Redis, you will be using the hashes structure. The list data structure, as you can imagine, lists, I want to add to the right, I want to add to the left, and also I want to scan the list, and you can do that. Also, list, it also provides you with blocking operations. What that means is that you can wait, that okay, if there is nothing in that list, please, I will wait. If something comes along, then Redis will push that to you. So that can be used for jobs and queue management there. And you can, of course, build your stacks and your lists using the operation that it provides. Then it's the set collection of unique values, and then it provides you with operations that you can do union, intersection, and differences, which I will cover with you. Okay. Then there are sorted sets, similar to sets, but each value, it has a score with it. So if you want to build leaderboards or you want to do additions and things like that, you can do it with sorted set. Again, it provides you with blocking operations. So if you are doing your messaging, you can also build priority queues using sorted sets. Then it provides you a geospatial index, that data structure that can be used for location-based services. Okay, so you can say that, okay, build your data structure, provide it with a location, and say that, okay, give me the nearest hospitals that are within 500 meters within me. Okay, hyperlog log, an exotic data structure, gives you the cardinality of a set, but uses 12 kilobytes. And again, we will cover that. Streams, one of the probably the most flexible data structure. These streams, they are append-only logs, so you can just use it if you are doing your time series, you can use streams for that. It's just an append-only log, and the values, they are map-like structures there. If you want to do, but again, it also provides you with blocking operations, so you can use it for messaging, for pub/sub, for consumer groups, and I will cover those. Okay. Now, let me just move and let's go through a few use cases. So, problem, simple cache. You have a database. You have your database. Whenever you make a request to your application, it goes to the database, gets the value, and you manipulate it in your application, and then return the request back to your to the application. Now, the database is slow. It's impacting the performance for your application. Okay. Now, you want to cache that data. Redis strings, they are perfect for that. They allow you to do set operations. They also allow you to do get operations. The maximum value for a string in Redis is 512 megabytes. But don't be fooled by that it's a string data type. You can think of string as just a binary data that you can manipulate. You can manipulate it at a bit level using the commands that are available through bitmaps there. Okay. So the strings, they store your text, you can store your images, you can store whatever you want to in there. Okay. So now you want to set this is a raw Redis command. Set, that's the command. You provide the key and then you set the value there. Okay. Now, you want to get the value, you provide the command get, and then you say, this is the key, and it will return you the value for that. Now, you're using it as a cache, you want to set an expiry, you can use the expiry command and provide the key, and it will expire after 60 seconds, so it won't be in Redis anymore. And when you are setting the command, you can also do that. Expiry, one thing to remember, the expire command, that is available on every Redis data. So you can set an expiry of those, okay? Now, you want to delete, you provide, again, delete user ID :1, okay? And how will it look in your code? Here, a popular Java library, Redis, there is almost a one-to-one mapping there. If you are using Python, if you are using JavaScript, if you are using Go, if you are using .NET, almost all the libraries, they give you the one-to-one mapping. For the more complex data types, like hashes, they map them to the hash or a dictionary or an object there. So you do not have, that's the beauty of Redis, you do not have the mental gymnastics that, oh, I'm storing my data in a different form, and in my programming code, I'm working with maps, I'm working with lists, I'm working with vectors, or I'm working with dictionaries. Redis is native to those, and it's also multilingual. That if you have a polyglot application using different applications, all the libraries, they can read and write the same data. And it is native there, okay? So now is the time that I just show you that if you want to learn more about Redis, so let's go to the string command. Yeah, string, it provides you a lot of different commands that, where you can set the value, you can get the value, you can do the, you can use it as counters also, and all that kind of stuff. So very, very nice consolidated documentation. If we go to the append command here, you will see that, okay, it gives you for each command, it tells you that, okay, as your data grows, how will it impact the performance? So here it's big O, it always will be big O of 1, it always will be a constant operation, okay? And then it also gives you patterns for that command also. Let's take another command. Okay, so if we go to the list command, okay, and if we go to the blocking pop, again, it tells you that, okay, what's the time complexity of the command, what's the behavior, and how does it work, and what are the different patterns. Very succinct, very nice documentation for each command. If you want to learn more about Redis, I would recommend that the easiest way, there are free university courses available on Redis Labs also, but probably it will take you a couple of hours. And then if you just read this article, it goes through all the different data structures, and it will give you enough information to start developing. Okay. Now, so I've covered this. Now, let's go for the user session use case. Now,
we have one question.
Yes.
So could you tell something about transactionality? Assume several transactional updates on several keys.
Okay, so Redis, it gives you, Redis has the concept of transactions, but those transactions, what that means is that they are atomic. There is no rollback there. So you can put a bunch of commands together and then execute them just as atomic, as one. Okay, so that is the transaction that Redis provides you with. Okay.
Okay, thank you.
Okay, so now, okay, so user sessions, the use case. All right, so you have multiple web applications. The users, they are making requests to those web applications. You go somewhere, you need to get the user profile, then serve that request there. You do not want to keep the users, you want to keep your web service stateless so that you can scale them independently there. And normally the way you keep your user sessions or user profiles, it is key value, field value, field value, field value there. Okay. The key here is that you want high speed and you want low latency. Redis provides you with a hash data type, which is perfect for that use case. It provides you with the set command. So let's go there, set command. That for user session 1, you can set up that, okay, this is my user session, this is the key, and different fields and values. User ID, that's the field, the value, name field, the value, IP field, and the value. And in a single atomic operation, you can set all these values. You want to read those values, you can use HMGet and say that, okay, that's the key, and I want to get these different fields. Okay. You can also use the fields inside as counters also. So you can also increment them, and it will be atomically incremented. So you can use the h increment by command, provide the key, provide the field, and increment the value. Okay. Redis, it is schemaless. So you want to add a new field, all you need to do is do a set, provide the key, and a new field that will be added there. Okay. You want to delete a key, a field, you can you can get a new field, you can also delete a single field also. So just like you're working with hashes or dictionaries, Redis gives you all the commands that you can do there. Okay. And of course, if you want to delete it, you can use the delete command to delete the whole hash there. Or if you want to set an expiry, you can also set up an expiry there. Okay. Now, switching gears, another use case, you have a website, that is serving news articles. When you are a reader, he is reading an article, and in real time, you want to give him a recommendation that's for similar articles. Rather than doing the processing in the background, you want to do that processing in real time for that. The same pattern that I'm showing you here, that can again be used for identifying fraud, that you can do the set operations or recommending similar purchases. Okay. And this pattern that uses sets. So sets, there are a collection of unique values. You can use sadd command to add the values. You can check that someone exists, does a set exist, you can get all the members of that set, and then you can do differences, unions, and intersections among different sets. Okay, and that's what we'll be using to model this problem. What we will be doing is that each article, it will have a set of tags. Okay, and then for each tag, we will have a set that will have all the articles that are tagged with it. So for tag 1, we have article 1, article 3. The article that the user is reading, it has tag 1, tag 2, and tag 3. So we can go and say that, okay, let's create our data structure. That, okay, tag 1, it has article 3, article 1, tag 2, and tag 3. If we want to read the values, we can use the smembers command. Now, to recommend an article that is exactly, that is similar to the article the user is reading, we know that it is tagged with tag 1, tag 2, and tag 3. All we need to do is do an intersection, okay? So if we do an intersection on these 3 sets, we will get the common article, which is article 3. And as I mentioned, this pattern you can use to find commonality for fraud detection and making doing in real time similar recommending similar purchases there. Okay. Sorted sets, again similar to sets. If you are playing a game, you do see a leaderboard. Okay, and on popular games, there are hundreds of thousands of users that are playing that game. And what you want to do is you want to maintain a real-time leaderboard. And the functionality it needs to provide, it should be that, okay, who are the top 10, who are the top bottom, what is a user's score, and what is the ranking of a particular user in the leaderboard, okay? Redis sorted sets, they are a good fit for that. And most of the gaming companies, they do use Redis for their leaderboards, because the other databases, they cannot provide the same performance, hundreds of thousands of operations per second, okay? So how do we model that in Redis? So the key, that is our game. We are adding a user with ID 1. And if we want more information about the user, we can use the hash to keep that information there. And we are adding a score, 10,000 for that user. Okay, and so on. As the user comes along, we can add the score for all the different users there. Okay. If we want to increment a user's score atomically, we can use the Z increment by command, provide the key and the user, and how do we want to increment it by, and it will increment the user score by that. Okay. Now, if I want to get the top 10 users, all I need to do is zrev range, provide the key, and say that, okay, give me the top 10 users. If I want to get the last 10 users, I can use the sister command, zrange there. Or if I want somewhere in between 50 to 100, you can also do that using the range command there. Okay. If you want to get the scores also, it also gives you the ability to get the scores. There is a zrank command. So if I provide zrank, the key game:1 and just the ID, it will give me that user score. If I want to get his score also, this is the user score, there is a command available also to do that. Okay. Again, very, very simple to do that. Now, the hyperlog log. Now, let's say you have a very popular website and you want to count every day the unique visitors that have visited your website. One way to do that is that you keep track of each user's IP. Now, if 1 million unique visitors are visiting your website, you need to keep a set of 1 million IP addresses. So the problem, the memory usage that grows as the number of the data set, the number of visitors grow, okay? And again, that's a similar problem in analytics also. You want to count something unique. So you need to keep you need to keep all the unique values there. But there is probably a better solution also there. Hyperlog log, it is a probabilistic data structure. Probabilistic data structures, they make a compromise between using between accuracy. Okay, so hyperlog log, it only uses 12 kilobytes. It's stored as a string. and the error rate is less than 1%. So for our use case, a user visits for that day, we keep a separate key for that day, and we add users' IP addresses. 1 million users visit, 1 billion users visit, it will never use more than 12 kilobytes, okay? If visits again, it will not be counted again, like we have just done it here, okay? And then at the end of the day, you can use the pfcount command, and it will give you the cardinality of that set. But it will never use more than 12 kilobytes, okay? Now, I'm moving to the messaging side. So on the messaging side, Redis provides you with a pub/sub mechanism. The pub/sub mechanism, it's a lightweight mechanism, and you can also use it for all the operations that I've shown previously. If you want to get notified on data changes, you can also use the pub/sub mechanism for that, okay? So one important thing to remember there is that Redis pub/sub is fire and forget. You publish something, the subscribers, if they are there, they will get the message, otherwise they will not. So it is at most once guaranteed there, okay? So now, how do you use it? The commands. We are simulating a weather channel, an application that it can subscribe to the channel weather for Stockholm, okay? So it has subscribed to that one. You can subscribe to multiple channels also. Someone has subscribed to weather Stockholm, weather Madrid, okay? Now you publish a message there, and all the subscribers, they will get that message. So right now we have published it to the Stockholm one, so they get the message there. You publish to the Madrid, there is only one subscriber there, so you can get that, the message that will be published there. But do remember that it is fire and forget, at most once guarantee there, okay? If you want at least once guarantee, you have Redis streams. Redis streams is a beautiful data structure, new data structure, part of Redis 5. You can use it for multiple of use cases, and I will cover a few of those. One is that you have producers, they are producing the data, and then you have consumers. You want to distribute the data, fan out. Very, very light data structure. You can create millions of streams in Redis, Redis database, and then you can, the consumers, they can listen for those different data for new messages, and in a blocking mode, okay? So a message comes here, each one, they will get that message there, okay? It provides you with a very, very simple, just one command, xadd command to add, and the entry, it is a hash-like field value structure. They are immutable. Each one, it has also its own timestamp. Okay. But what you can do is, so a few samples, a single producer, a single consumer, you can do that, okay? A single producer, multiple consumers, you can also do that and push the messages to multiple consumers there. And extremely efficient, probably 1 millisecond or less latency from producer to consumer there. Then in many use cases, you have a producer that's producing the messages, and then you want to send the messages. You can have a group of consumers, and the messages, they will only go to one of those. So a message comes in, it goes to the image processor 1, another message comes in, it goes to the image processor 2. So you can scale your processing also. Redis, it will also keep track, who did it send the messages to? So you have all the ability to, if the image processor is processing the message, but it dies and it hasn't acknowledged the message, you can keep track of that and send the message to another image processor. So it gives you at least once guarantee also there, okay? And you can scale your reading. And of course, you can combine them. You can have multiple consumer groups. You can have multiple consumers on a single stream, and still very, very lightweight. So you can use it for your messaging very, very easily in a very, very lightweight way, and a performant way there, okay? A few best or worst practices for Redis that I want to cover. Always set a password for your Redis database. Don't use the keys command. There is a scan command. If you want to get all the keys, use that. That will not block it. Number databases, Redis, you can have namespaces in Redis. Do not use that. As I mentioned, lists, hashes, sorted sets, they can have billions of entries inside them. So don't do an unbounded return if you have millions of entries there. Always use pipelining if you can. What that means is bunching up the operations and sending just one network request there. And most of the libraries also, they support pipelining there. Okay, beware of hotkeys, because that will impact your scaling. That if you have just one key and you're hitting it, you will be getting hundreds of thousands of operations per second, but you won't be able to get millions of operations per second because you will not be able to scale it. Okay, and for your important data, Redis also provides you with persistence. So use persistence if the data is important for you. Okay. Now modules. Markus already mentioned modules. Modules that enhance Redis. You can write your own module in C, and it's quite easy if you know C. You can write your own module and extend Redis there. Just a few different data structures. Redis gears data structure if you want to do processing inside Redis or event-driven processing. For example, you write something to Redis, you want to write it also to the database rather than doing it into the application. You can use the Redis gears module. What that allows you to do is give you Python code, and when something happens, your Python code that will be notified, you can put it in a stream and write to the database in the background. That's just one use case. By your imagination, that's the limit for using Redis gears to do event-driven processing. It can also listen on streams, and then you write something to the stream, and you can also do your processing on that stream inside Redis. So it makes Redis serverless. Okay. Redis TimeSeries module provides the TimeSeries data structure, provides downsampling, aggregation, labeling, retention rules, and all that. Again, available open source. Go to the website, download them, and play with it. Okay. Redis Search, one of the most popular module. If you are using Elasticsearch and the performance is requirements, you can use the Redis Search module. Provides all the basic functionality there without any of the cruft. Okay. And you can use it full text indexing. You can do autocomplete, exact phrase. You can do range searches, and one more, because Redis is a key value store, you can use it as a second to build secondary indexes also if you want to do more complex searches there. Okay, SQL-like searches there. Very, very good use case for that. Redis Graph turns Redis into a graph module, supports Cypher query language. The main differentiating point is that it is in memory and it is extremely fast. It uses matrices rather than lists to store the data. So traversing relationships at different depths, they are just matrix multiplications and transpositions there. Okay. And then if you want to use, if you have JSON documents and you want to manipulate the JSON documents, if it's just as a string, you can just use the string data type. But if you have a use case where you want to get just a subset of your document, then you can use the Redis JSON module and store your JSON documents, and it gives you commands to get a substring, or also using JPath update just parts of the JSON document. There is a probabilistic data structure built like hyperlog. If you get a chance, if you're into analytics, it supports Bloom filters, it supports cuckoo filters, it gives you top K, and it gives you counter min squares. So if you are doing big data analytics and you are aware of those probabilistic data structures, they are a good use case to use those. Okay. But the key thing is, all of them, they are very, very fast. Okay. Now Redis 6. That came out recently, and Redis open source. So the things that are part of Redis 6, access control lists. Previously, Redis only supported just password authentication. Now you can, at the key level, provide that, okay, this user or this application, it can only access these certain keys, and what operations can it perform. So it reduces the surface. And you can say that, oh, this application, it can only do read operations. This application, it can just do read and write operations. Or these applications, they can only access keys with these certain prefixes. TLS SSL encryption, that was already in Redis Enterprise, but now also is part of Redis open source. So you can go up to TLS 3 On the client side, you can do the encryption, and also for replication, and also in the cluster communication, you can do replication. There is also cluster proxy available, which makes clustering easier for you in Redis open source. There is server-assisted client-side caching capabilities built in, which the libraries will have to support. What that means is that in many cases, the clients, they would read a key or a value, and they wanted to cache it. But there was a problem that if it was updated in Redis, there was different patterns, but not all of them very efficient to invalidate the key on the client. Now, Redis provides that mechanism, and the client-side libraries, they will start supporting it. And I remember, and Redis, it has a huge ecosystem of libraries, and eventually they will start supporting this. Then there is a new REST 3 protocol. The old protocol is still supported, but the new protocol, it provides more semantics. So the libraries, they will be easier to write there. And multi-threading on the IO Redis on the database touch, that still is single-threaded, but on the IO side, there are more capabilities for multi-threading in open source Redis. And Redis, since version 6, it always adds a new lulwit, and this is the new lulwit, just a thing that some arty stuff, this is part of Redis 6. And then there are improvements on the modules. So I think we are almost on the time, and I have very, very quickly covered most of the things. And now I am open for questions there.
Okay, thank you. So we have one question, although I wanted to also ask about Apache Kafka and Redis streams. Could you tell something about?
So they solve similar kind of problems with a different heart. Okay. So Salvatore, he took the concept for Kafka for the consumer groups from Apache Kafka, provides similar kind of functionality. There are a few differences, like on the partitions on the semantic side. But if your use case is that, oh, I want to just use the streams, just want to use them as messaging, and I want a lightweight mechanism, please do look at the streams if they meet your requirements. Kafka, it does have a bigger ecosystem for integration and that kind of stuff, but it is also much complex to install and manage there. If you are already using Redis for your database, it's a no-brainer to use streams. Also, if you want lower latency for your certain operations, Redis streams, that is a good use case for that. Okay. Does that answer your question there?
Yeah, I think. But is this possible to replace one with the other one?
In this many use cases, yes, it is possible. Yes, because they are providing you with the streaming functionality there. Yes.
Okay, so another one. As I remember, Redis is in the memory database, and correct. You described setting expiry on the records in Redis to free up the memory. Is correct. There any techniques to optimize memory consumption?
So, okay, so yes, there are a lot of techniques. Redis, it always has built-in techniques. So let's say if you're using a hash set, if it's less than a certain size, it will use it in a different format. The same is true for lists. The same is true for sorted sets. But there is no magic. You can compress your data in many use cases to do that. But there are optimizations that are already built into Redis to optimize for the memory. But Redis will take whatever you give it to Redis. Okay. Does that answer your question?
Yeah, I hope so. So I don't see anything. Anyone?
Let's give a couple more seconds for the
okay.
questions maybe.
Sorry, I didn't hear that.
I said that let's give a couple more seconds for last questions maybe, but I don't see questions anymore.
Yep. Okay.
So,
And,
yes, please proceed.
if you want to learn more about Redis, there is a Redis University, Redis.io, the open source website. There is also Redis University. You can go register for the free courses and go through their self-paced courses. And it is also quite a good resource. So I've added I've added that. Okay.
Okay. So Markus, Kamran, thank you very much for your talk today. I believe we set up new record when it comes to questions asked in the single session. So I'm very glad to see that. And once again, on behalf of Tomek and Philip, thank you very much. And I will stop recording right now.